Let's try it again. This time we're going to use cosine of 1/3 x. In order to find our changes right here, we notice that we're multiplying x by a constant first, so we're going to get a new period. And I'll just walk through how this all works. The new period is found by taking 2 pi, or what would normally be our period for cosine, and dividing it by 1/3. Well, 2 pi divided by 1/3 is equal to 3 over 1 times 2 pi. That's 6 pi. So our period is 6 pi, which means we're going to start at 0. We're going to end one full cycle at 6 pi. And we need 5 total key points, each of them 1/4 of the period apart. So key points are found by taking 1/4 times the period, 6 pi. So 6 pi times 1/4, that's 6 over 4. That's 3 pi over 2 apart. And so we would start at 0, and we'd start adding increments of 3 pi over 2 to get all of our key points. So 0 plus 3 pi over 2, well, that's 3 pi over 2. Plus 3 pi over 2, 3 pi over 2 plus 3 pi over 2, that's 6 pi over 2. Hey, that's 3 pi. 6 pi over 2 plus 3 pi over 2 more gives us 9 pi over 2. It's going to write it all out, but hopefully you can get it by now. We add another 3 pi over 2. We're at 6 pi. All right, how about our y values? Well, the y values, just like the original cosine function, there's no reflection, the value is still 1 in front of this, are going to go 1, 0, -1, 0, and +1. So I'm going to plot those points, those main key points, along my x-axis, evenly spaced. And we see that each of the key points are evenly spaced at 3 pi over 2 apart from one another, and I've got them in completely reduced form as fractions. And that since we're following the cosine function, we're going to start at 0 and go to 1. 3 pi over 2 this time will be at 0. 3 pi will be at -1. At 9 pi over 2, we're back to 0. And then at 6 pi, we're back to +1. And so following the bouncing balls here to get our picture of our graph, we see that the function passes through each of the key points. It looks like any other cosine graph in the universe. And the only real difference between this and what our original graph might have looked at is that it is, well, 3 times as large. In other words, I could fit 3 full periods of my original cosine function here, where I might have only had one before, which kind of here is illustrated in gray. You can see the period here is 2 pi. Right? So if we had 2 pi ending right here, 2 pi, 3 pi, 4 pi right here, 6 pi, right? You can see that there's several cycles going on. So this is what that period does, that period change does to the cosine function. Our amplitude, however, our amplitude is still equal to +1. Our period, in this case, is equal to 6 pi. The domain is all real numbers, as it was before, and the range is going to be the set of values from -1 to +1. Okay, more to come.